Welcome students. I hope you are doing very well. I am Dr.A.G.Srinivasan, who is a professional mathematician, will take a class, a set of classes for you on this subject, Analytical Geometry 2. I hope you also learned Analytical Geometry 1 and other geometrical ideas in your previous classes. Let me start with a simple example. Why should I study analytical geometry? The answer is very simple. The whole universe, the whole galaxy, the whole world, everywhere geometry plays a very important role. Without geometry, nothing can exist in this globe. Whether it's a raining, whether it's a summer season, or anything and everything decides by geometrical configurations. But the humankind has got limitations. They can only visualize a three-dimensional geometry, they cannot draw, or they can only draw a two-dimensional geometries. It's practically difficult or even impossible to imagine more than three dimension. The nature works in multi-dimension. That's actual fact. So mathematicians were struggling to tackle this problem. What was the problem? They can only imagine three dimension. They can't draw. Maybe nowadays you got 3D printers, but even that, after 3D printers, you cannot go to 4D printers and so on. So mathematicians struggle to attack this problem for thousands of years, and later they found an excellent subject called analytical geometry. Even the recent subjects like machine learning, artificial intelligence, etc., they use tremendous geometrical patterns. In turn, analytical geometry for their interpretation of the problems. Let me demonstrate two examples. One from the real world, another one from mathematics. You are watching this video in a television or in a mobile or in a computer monitor, all that. Do you observe all of them are rectangular in shape? Whether it's a TV or a monitor or a mobile, you are watching them only in the rectangular shape device. Though there are some curved TVs are coming, curved monitors are coming, but it is not picking up. All over the globe, only rectangular monitors, rectangular mobiles, rectangular TVs have been manufactured. You know what is the reason for that? There is a geometry behind it. There is an analytical geometry behind it. So therefore, without geometry, the humankind cannot survive, the globe cannot survive. Let me give one example mathematically as well, because then you understand the power of analytical geometry. Let me demonstrate in a minute's time how powerful this analytical geometry is to handle as such. Let me take a graph, x-axis, y-axis graph. I have a graph which is x-axis and y-axis. I take a line, I just draw a line which makes an angle alpha with respect to x-axis. So I'm just taking a line which makes an angle alpha with respect to x-axis. Alpha being an angle, you know pretty well that cos square alpha plus sine square alpha is identically equal to 1. Whatever alpha it may be, we don't care. For any angle alpha, cos square alpha plus sine square alpha is identically equal to 1. And this is one of the important theorems for, in geometry we have been learning. Let me do something else. and give you a new interpretation of the same using this. What is that? It's simple. Take again x-axis, y-axis. I take alpha as an angle made by this line. I will call this angle by beta. So what is it, beta? Beta is an angle made by that line with y-axis. Let's find out what is beta at the moment. So by simple mathematical property of triangle, alpha plus beta plus 90, this is 90 degrees, you know that, is equal to 180. Sum of the angles of a triangle is always 180 degrees, you know that. A little manipulation tells you that beta is equal to, so 180 minus 90, then take this alpha this side, you easily get, probably you will get 190 minus alpha, because 180 minus 90 and then alpha I brought it, or you can also write alpha equal to 90 minus beta, or same. Now what I'm going to do is I go to the formula and substitute that alpha value here. Let's see what happens. This is equal to cos square alpha. I am not disturbing that for time being. But instead of sine square alpha, I would write sine square. What is alpha? Just now we saw 90 minus beta. Of course, this is still identically equal to 1. There is no change in that. And I continue this step like this. Again, this is cos square alpha. And sine 90 minus alpha, all silver teacups, no, like we have first quadrant, second quadrant, all the discussion, which I am not discussing. This sine becomes cos, you get cos square beta is equal to 1. So what we have done is that if a line makes an angle alpha with x-axis and beta with y-axis, we have verified, we have proved that cos square alpha plus cos square beta equal to 1. As I told you already that I cannot imagine more than 3 dimension. I can visualize a 3 dimension. I think I told you. Maybe today it is not correct because you got 3-dimensional printers have come. You can even do something about it. But not, more than 3 dimensions certainly. Suppose I take the same argument in a 3-dimensional axis, which is x-axis, y-axis and z-axis. I can't draw this because it's a 2-dimensional board, so I cannot draw the 3-dimensional graph on that. It's not possible at all, you know that. I can't draw even a line. I can't draw a line in that because the line is on the space, you know that. Suppose that line, imagine please, suppose that line makes an angle alpha with x-axis, beta with y-axis and gamma with z-axis, like here, no? This line makes an angle alpha in x-axis, beta in y-axis, something like that. So there is a line in space which makes an angle alpha in x-axis, beta in y-axis and gamma in z-axis. You can easily show in one stroke that cos square alpha plus cos square beta plus cos square gamma equal to 1. Even it is identically equal to 1. Let me now go to the next level. You have got n-dimensional. Please remember, human eyes, human mind cannot imagine more than 3 dimension. Now I have got a situation of n dimension. N can be anything, it doesn't matter. If a line makes an angle alpha with first dimension, first axis, beta with second axis, gamma with third axis and so on, we can easily show using analytical geometry, cos square alpha plus cos square beta plus cos square gamma, all is equal, sum of them will be equal to 1 always. So without even drawing the geometry, without even knowing the behavior of a geometry, you can find out the properties of the geometrical configurations. My dear students, I already told you the rain example. The earth, the mother earth alone gets rain. It is not only because of the shape of the earth, not only because of the rotation of the earth, but also the angle it makes, its rotational, etc. So if you study analytical geometry, literally you are studying the whole nature, whether it's physics or chemistry or engineering or anything. If you study analytical geometry, you are studying everything. Isn't it a surprise? So that's the first part. What you are going to learn in our course. Let me summarize for 2-3 minutes what you are going to learn in this course. Of course, I am now taking Analytical Geometry 2. That means in your previous classes, you must have learned Analytical Geometry 1, which of course I will not cover. I think some other people will be covering on that. What I'll be covering, of course, is first revising the basis of geometry, starting from a point, a line, a circle, an ellipse, a parabola, an hyperbola, a rectangle hyperbola, in general conics, and so on. But that is not important. What is important is how we are going to handle a given geometrical surface analytically, mathematically, and investigate. That is the objective we are going to give it. If you are joining engineering, for instance, without this, you cannot understand your department paper as well. The conclusion is, without knowing the geometry, the geometrical behavior, the angle of inclination, all that stuff, it is very difficult to understand the behavior, the properties of that system. My dear students, let me take this opportunity to tell you that you will be getting a tremendous surprises when you do analytical geometry in the next class onwards, starting with a point and the line and the circle and so on. Kindly wait eagerly. I am also eagerly waiting to share my knowledge, because by end of the module, after discussing this AG2, you are different than what you are. With this, we'll stop the today's presentation. In the next class, we'll start with the technicality of Analytical Geometry 2 in a detailed manner. Thank you very much. Thank you.